Okay, so I'm going to do this as a just concluded two animations. We have seen this current animation before, but let's look at the deep circulation once again, just to kind of re-emphasize the thermohaline circulation. So sea to air heat transfer, evaporative cooling, causes the North Atlantic deep water formation. In the Southern Ocean, there are more complicated processes happening, brine rejection, cooling, evaporation, etc. It's a much colder ocean. Here you're bringing warm waters and facilitating evaporation and heavy water formation, whereas in the south it's already very cold, so you need different processes. Nonetheless, we already learned about Antarctic bottom water, Antarctic intermediate water, and North Atlantic deep water, which form most of the water masses. And you can see the blue arrows zipping down are the deeper part of the deep water circulation, or the thermohaline circulation. Everything is coming into the Southern Ocean and circle around, mix up. It's referred to as mix master, and if it hasn't been, well, actually mixing bowl, because mix master is something Arnold Gordon uses for the Indonesian seas. So this is the mixing bowl where all these waters are mixed around, circulated and pumped into the Indian and Pacific Oceans. Indian Ocean is a shallower, smaller ocean which recycles the water back to the surface and out, and the Pacific water goes up, becomes surface water, comes back across the equator through the Indonesian seas. So that's kind of the interbasin tropical pathway for the thermohaline circulation. So the Indian surface water mixes with the Indonesian through flow water, as you can see here. I have lost my cursor again, but that's then going to go around Africa, southern tip of Africa, cross the equator into the North Atlantic, and supply the sinking region again. If you're sinking, you have to replenish this water, and this warm water is coming through the Gulf Stream system, of course, right? The Gulf Stream then becomes part of the meridional overturning circulation, as opposed to the other current like the Kuroshio, which is not part of the thermohaline circulation. Okay, I will end with one very nice animation from NASA that shows the ocean eddies, which I will do in the next podcast. So just make sure you understood the density-driven thermohaline circulation and the global conveyor belt, right? Very nice. Now we are almost to the end of this chapter. The rest of the chapters are much simpler in terms of the physics, till we come back to global warming at the very end. Okay? Enjoy.